Hello guys. Today we are going to start Chapter 11. The title of Chapter 11 is Covariance and Correlation. And you can feel, like maybe you have feeling what we are going to do. To start, so this chapter is quite different from what we learned in Chapter 8, 9, 10. So Chapter 8, 9, 10 were about statistical inference methods. Estimation in Chapter 8 and 9 and 10 were about hypothesis testing. But this chapter, Chapter 11, is more similar to Chapter 3 and 4, where we learned basic numerical measures like mean, median, variance, standard deviation, range, interquartile range, percentiles, blah blah blah. So remember, we learned measure of location, measure of variability. These measures are basically to describe or summary, characterize or like present the basic properties of a random variable. But these measures were limited to only one variable. So when you calculate the mean, it should be from one variable, and when you calculate the variance, it is also only about one variable. But now from this chapter in Chapter 11 and in Chapter 12, so in two chapters, we focus more on the relationship between two variables rather than a single variable. So we are going to learn three most basic and most important measures or methods. One is covariance, another is correlation coefficient. So these two are the main topics in this chapter. And in the next chapter, we are going to learn the regression model. Regression is so famous, I think you may have heard about this. This is the most important method in economic research. So Chapter 12 is the last chapter, and it is about the regression model. And a little bit of I can say with a little bit of exaggeration that everything we learned in Chapter 1 through 11 was just a preliminary step for Chapter 12. That is our final goal. And if you take the next step, I'm going to teach ECO 420 next semester. That's if you are interested in economic statistics, data analysis, quantitative analysis in economics, then you can take Econ 420 as the next step after this course. And then 420 is basic. We'll start from the regression model, and you are going to learn variations of the regression models in that course. Maybe whole semester is devoted to regression model and its variations and some other issues related to regression models. So regression is so much important, and this is a must-know for any econ major. And as I said, I am using slides from last year, and this textbook is Keller textbook by Keller. But if you want more reading materials, you may simply search for correlation coefficient or covariance. Then you will see a lot of materials or chapters where it explained where these are explained. Then that should be pretty much the same material as I explained now. Okay, let me start with an example. It's about climate and economy. It's a real data. This data is real. And in the data, we have 183 countries, which is almost all countries, except for a few. I don't know why some were dropped. Maybe because there is no climate data. Anyhow, for these countries, we observe average yearly temperature between 1961 and 1990 in Celsius. And also we have GDP per capita in 2005 in US dollars. And the data was from this I just happened to came across this data, and I used it as an interesting example. However, so this is just an example, just a kind of motivating and fun example, but there is little economic interpretation we can get from this. There is no economic intuition what's the relationship between GDP and temperature. It's just an introduction, has no deeper meaning. So let's look at these examples, tables. So I ordered countries from the richest. So then the highest GDP per capita is from Qatar, and Luxembourg, Macau, Singapore, Kuwait they have the highest GDP per capita, and their average temperatures are like these. So Qatar, Macau, Singapore, Kuwait are quite warm. They are warm countries, but Luxembourg is rather cold. Average throughout the year is only 8 degrees in Celsius. So 8 degrees, if you're wondering what is how much is 8 degrees, it's about 40 something, like slightly below 50 degrees. Okay. Then, by the way, it is impossible to, as usual, it is impossible to list all 180 countries. So that's why we have to consider summarizing them, and like we have to calculate summary measures, numerical measures that literally summarize the information in 180 countries. And alternatively, you may use a graph. This is a scatter plot. You may have heard about scatter plot. In this scatter plot, you have two axes. On the horizontal axis, I list average temperature. So 0 degree, average is 0. Russia and Canada is on average below 0 degree, freezing on average. And highest is around 20 something, 20, like between like 27, maybe 28 is the highest average temperature. And on the vertical axis, we have GDP per capita from 0 to 90,000. So highest is Qatar. So on this two-dimensional plane, of course, this horizontal axis is x-axis, and the vertical axis is y-axis. Excuse me. Then you can locate each country on somewhere on this plane. For example, Qatar has very warm weather. Average is about 27 something, and very rich. GDP per capita is about 80,000 something. So the location of Qatar is here. USA is here. The average temperature in USA is about 9 degrees, and GDP per capita is about 40 something thousand. Norway has a similar GDP per capita, but it's much colder than USA, and Canada, Russia, and so if a country is located upside high, then it means the country is rich, and if it's on the right, then it is warm. On the left, it's cold. So rich, poor, warm, and cold. So the countries are distributed somewhere on this two-dimensional XY plane. So we have 183 countries in our data. So if you count how many points, how many dots on the graph, there must be 183 points. Right? One country is one dot, or one observation is one dot, and from one observation, even though I say one observation, but from one observation we have two variables. So from one country we have temperature and we have GDP per capita. These two variables are matched to, like, corresponds to one country. So I would say the observation is there are 183 observations, and from each observation we have two random variables. It's like you are doing survey, but in one questionnaire there are two questions. So then one respondent one respondent answers two questions, so you have two variables. So number of variables can be extended, but number of observations is more important in our analysis. That's number of observations is the sample size, n. In this case, number of countries is the sample size. So don't be confused. We have paired variables, and using the paired variables is observed repeatedly, and from there we would like to calculate some measures for their relationship, the relationship between two random variables. Okay, scatter plot is here. And by the way, from this scatter plot, it's hard to see what's the trend. Do you see some trend? It's hard to tell. There may be some or there may be not, but there is too much variations and messy. But what we want to do is something like this. So we have two major questions. Do colder countries have higher GDP per capita? This is about direction. This is direction. So if like say colder countries tend to have higher GDP, it's about their whether it increases or decreases as temperature drops or increases. That's about the direction. And second, how strong is the relationship? It's about strength. Is the temperature an important determinant of the GDP per capita or not? How strong is that? So keep that in mind. We are interested in these two questions, and to answer that, we are going to use this trend line. Trend line is what we are looking for in this model, in our framework. We would like to draw a trend line, and to answer these questions, what I'm going to do here is the trend line is downward sloping, which means as the temperature increases, GDP decreases, right? GDP decreases, so that captures the direction of these two, the relationship. And second, strength is about the deviations. The observation, even though the red is the trend line, many observations are far away from the trend line. That tells you that the strength is weak. So you can think it this way. So remember, in chapter 3, we learned measure of location. Location is about center, which summarizes every information into one number. And in chapter 4, we learned deviation from the summary, the mean, the center. And similar, here, it is not the center 1 point, it's not anymore 1 point. To summarize these two-dimensional information, we have to make a line instead of a 1 point. So the mean was 1 point, which was just 1 point summary. But here, the simplest summary should be a line. That is the red line, trend line. And then, however, it loses a lot of information contained in the data. So next, we have to study the deviation from the trend line, and we have to study how far the observations are from the trend line. So this is what we are going to do. However, I have to give you a warning. This is not a fully general or a perfect model in the sense that we only consider trend line. So it may be a curve or something else, but that makes the model too much complicated. So there are models, but I cannot teach them at this point. That would be too much involved. So we are going to restrict our attention only to a trend line, linear relationship. So we assume that the relationship is like this, stable line, just straight line, even though there may be some errors, but in general, the trend line should be a straight line. And the examples of nonlinear relationship is something like this. There is a curve, U-shaped curve. It decreases first, and then at some point it increases again. So obviously it is not a linear trend. There is no linear trend. if you fit this data into a linear trend, you are going to have a flat line which has no meaning, which is actually a wrong interpretation of the trend. But so in this, if you expect some nonlinear relationship between the two variables, the method I'm going to show you does not work. So you have to study more to make this model more comprehensive. But at this point, we are not considering such a relationship. Another example of nonlinear relationship is something like kink. So the relationship is flat and then steep. So the slope, even though each part it's linear, it's straight and then straight, but overall it's not linear. If you use a linear model to this example, you are going to have just one slope which is in between this flat slope and steep slope. So it may mislead to a wrong conclusion. So be careful. We are only considering only linear relationship. So nonlinear relationship cannot be handled in this model. Okay, I'm going to continue in the next video and look forward to that. See you later.